Yo, what up? Hello, my name's Solar Loon. Welcome to my stream. This is a little bit of an impromptu stream because I was working on something anyway, so I was like, well, if I'm gonna be working on it anyway, I might as well stream, I guess. That's an idea. Let's see. Okay. Let's get some music going. Cool. Oh, my camera as well. All right, cool. So what I'm working on here is basically some pathfinding stuff. So in the last video, I think I was working on this like arcade game, and it has some pathfinding. I have an enemy that basically is pathfinding, and I wanted to add the ability to like have the enemy walk off an edge to, like, you know, basically rather than walking upstairs to a position and then walking back down, it could just walk off the edge if possible. So in order to do that, I need one-way pathfinding. So that's what I'm implementing. I got it all working, but there's something a little weird about the way I was doing it. So I am kind of rewriting it here. So we'll see how this works. Also, that loop is horrible. Let me fix that because that's not, it's not good enough. Let me fix this loop real quick. Oh my gosh. There we go. Give me something like this. Yeah. Let me try this. Yeah, that won't work. Let me close it and reopen it. There we go. All right. So yeah, let's take a look here. So the idea is that basically we put our nodes, our grid points in a list, in a slice. This is Go. And we want to know basically for each node's neighbors if they are low cost, and if they're low cost, then we basically say, okay, that's a valid jump from the starting node, or, you know, whichever node we're looking at, and then we just kind of fan outward. That's the idea, and then we should be able to trace it back, but it's not working. So that's what the current situation is. Or it is not working. Let me take a look. Yeah, all the costs are the same here. Yeah, it's not good. So let's see what's going on here. Cost so far is next cost. That might help out a little bit. Let's see. Yeah, that's, all the costs are the same. Next stat cost so far. Or maybe it needs to be, actually, yeah, I guess it should start at 0. Okay, so the path couldn't be determined. Let's see. Cost so far is 0. Cost so far. If the connection is passable and it hasn't been checked, yeah, I guess that's probably part of it. Might also be. Okay, so the goal is found. But there's no grid points in the path. So we're like, okay, the next is goal, okay. Goal found, 0. Oh. Really? Okay. Wait, no. Hold on. So the goal's being found. Goal found. Okay, so there's the grid point. The previous link isn't set though. Checked point. All right, so we can start off with that being checked. So we say the 2 check next is the rest of this. We loop through the connections and then we say, okay, has it been, have these been checked? No, okay. Set their cost so far, set their previous link. I mean, this all seems fine. I feel like the order is, like everything, I'm doing everything I should be doing, but for whatever reason it's not working. Previous link is nil here. Why is it nil? So next, cost so far, 24. Okay, so then it says goal found. Checkpoint. Let's see. Checkpoint. This is the goal, right? 24? Oh no, 16. Okay. So this is the connection. So this is 216. All right. It's the length. Okay. So if C is passable, something's not right, and I'm not sure quite what. Maybe there's floating point inaccuracies here. I feel like this should be fine, but maybe it's not. Oh, well, that's probably part of it, actually. I forgot. All right, cool. So this does seem like it's working. We'll try some things real quick. I feel like this is indicative of a problem. Yeah, this couldn't possibly be a shorter path because you're going out of the way first. Okay. That's correct. This is not. From this to there. Okay. Let's see. Let's set the constant. Let's see here. Yeah, it does seem more performant than my previous approach. Okay. All right, so what we want to do is figure out why it's giving us this response. So if you have the cube here, or I guess here actually, when you do this, it goes across first. It should never go across first, basically. Yeah. So let's see here. What we'll do, it will basically just create a simple test that's basically just that. So why does it go far first? Let's see. See, 2 goes so far is greater than next cost. So let me think about how this is happening. It's probably gonna be simpler as well if we like merge these two. No, that's correct. Is it about distance? Why does it go far on this one? Let's see. See that passable checkpoint. Next cost is next that cost so far. Okay, let me see. I think I'm getting close. Where I is for the, oops. 0, I is less than limp to check. I plus. I think I'm close. Okay, so, and the goal is 14. Wait a second, goal. Okay. So 0 is this one. Or no, it's starting here. So 0 and 1 is 15 and 16. And then try 17. Okay, hold on. So let's see. All right, so it's this one. Zoom in. So it's this one's negative 0.5 and 0.5, and then this one 0.5, negative 0.5. Then this one and $14. How does it get to 14? Zero, one. Oh, 0. I guess it's 0, 1. Then 0, 1. Hold on, there's something weird about this. Grid points. If C.2 that cost so far is greater than next cost. I think that's correct, but let's see what happens if it's just like that. Okay, so that works. That does not. Next cost is next that cost so far. Oh, hold on. Alright, so I'm trying to figure this out, and I'm close, I feel like, but I'm not sure. What do I need to do? It's clearly going the wrong way. Well, let me break out. Something like this. So I guess what we need to do, even though I really don't want to do it, like if we have a node like this, right? And we have a node here. And let's say we have something like this, right? An arrangement like this. Oh, hold on. So if we have a situation like this, right, where the nodes are connected around, and you have quite a few nodes like this, it might double back on itself and end up with this. So like if this is A, let's say this is the start, right? This is A, and you want to go to, let's say this is B. Well, you get the point. Let's say how you're going from A to B. Regardless of how it determines the neighborhood, it basically should stop once there's no more nodes to check, I guess. Even if it's like, oh, I found a neighbor. Let's say you found a neighbor like this, right? Let's say this is it's like the first neighbor check, it finds this path. It's like, okay, here's a good path, but there could be a shorter path. So I think we need to basically run through every node, check every node until there's no more neighbors, and then we can determine what's the shortest path. But how do we do that? So in this case, this is one path, and this is another path. How do we know how many paths we have? I don't want to have to maintain a list of previous nodes, but that might be what I have to do. No, I don't really want to do that. That doesn't. I don't see how I could even manage that. Let me think. Okay, let's see. I feel like this is the trick. Like, if we are maintaining the cost of the path, and we're basically nuking paths that are too long, we're naturally going to end up with a shorter path, right? Like if you say, let's say we go from A to B first, and the cost is, let's say 3, and then you go all the way around here, and the cost ends up being like 15. This won't set the previous link to be this one, because the cost is so high. It's higher than what it already has. So I feel like I'm doing the right thing here, but I'm clearly something's not working the way it should. Maybe the cost is wrong. Cost so far is next dot cost so far plus c dot cost plus c dot length. Okay, well that's probably why. Should be maybe I could just maintain the cost like this. If I can maintain the cost here, no, it needs to be additive according to the nodes, right? Next dot cost so far. So node A has a cost, or no, it doesn't have a cost. Node A is connected to node B. That path, that jump has a cost. So it's c dot cost plus c dot length. That's fine. But cost so far of next. No, I feel like that's right. Yeah, it's connections. Yeah, I feel like the cost is correct. But I also feel like the cost might be like one off. Like in this example, I guess I can do that. Hold on. Let's try this. Yeah, this might help us out. Help us see what's going on. All right, so 0.5 and -2. It's 2.5. -3.5. 1, 0, 1. Yeah, okay, so 1, 1, 2.5. It is a little further. 2.5. And then 5.1. No, it should be shorter, shouldn't it? If this is 0, 1, 2.5, this should be like 3 and some change or something. Yeah. Okay. So I feel like I'm on the right track. Yeah, so an alternate path is never found. Okay, let's try this. I want to see if this is a matter of something else going on. Wiggle found. So that means that we should have run through every node. C.2, that cost so far is greater than next cost. I feel like I'm on the cusp of this. Let's see. Okay, it's 14. Costs 0. Greater than next cost. I'm so like almost there. I'm like, what am I missing? So the problem I feel like is that, oh, that's why, because we're only checking the point once. So we only want to check the point So maybe, because we don't want to recheck a node unless if you haven't checked it and yeah, I think what I want to do is basically say if you haven't checked the node, then check it. If you have checked it, then only check it if you found a better path, basically. So if not checkpoint, or so I mean cost so far could be, if cost so far is 0, then that means that it hasn't been checked, I guess. So see that. Okay, that might be what I'm missing. Nope, crash. Let me think. So previous is that one. Previous is that one. So it's going back. Oh, okay. Okay, I see. I think I see what's going on. So we need to go to point. I think that might be it. Okay. Let's see. Excuse me. Oh no, I don't have to do that. I can just, if c.2 is not equal to point and either of those should help. Maybe. Okay. So I think that might be what we need to do. Yo, I think it's working. Okay, cool. So I think that's it. We will. I'll just leave that the way it is. I just want to see it. Beautiful. Okay, so I think there's a link between these two, right? Yeah. So if I wanted to, if I went here, I want to go here. All right. What if I'm here? There we go. That's good. So this is a little weird looking because of the low resolution, but basically this is a pathfinding system. And I had this before, this worked before, but this is an upgrade because apparently it's working a little faster, I think. But also now each connection between grid points is composed of two one-way directions, one-way connections. So for example, let's say we have this, area over here. I can take the center node and turn off the connections. So now I can't go from here across to here because this node doesn't have any more valid connections or passable connections heading north, south, east, or west. I can go there still because there's connection from this node to this one, but there's no connection from this one out, so I can't head anywhere else. So that's good because that allows me to have one-way traversal. So for example, I could have a for my arcade game, I can have nodes that go upstairs and stuff like that, and then a node at the top that basically leads back to the bottom by means of just the enemy just falling off the platform. So he'll like be able to figure that out. So that's kind of one of the main reasons why I went through this, which is good. I think that it's overall a really nice feature and it feels pretty solid. I'm like I kind of feel like I should have just one. I kind of feel like I should just have one connection for both sides of the connection, like one connection for A to B and B to A. They both share the same connection. But I mean, I feel like it's either that and you have weird like directional values, or where it's like, oh, this is a connection between nodes A and B, but the direction in the connection is like only A to B or only B to A or bidirectional. And the same thing for cost, which is weird, like a cost, two cost values, like a cost when you're going from one node to another and a different cost when you're going from that node back. It just feels like it might be easier to just have one connection per direction. And so if we go from here, I think I'm printing stuff still. Okay, so from here all the way over here, that is a 15 hop pathfinding path, and it took 29 like microseconds, which is pretty good. That's really good, actually. That's kind of insane, actually. That's really good. I don't know how it's that fast. That's really good. I guess before I was using a map as like a set, and apparently that was just dumb slow, I guess. I was using a map to basically act as a set to like put in nodes. Well, I guess I optimized it in a couple ways. I no longer check to see if a node has been checked. I just basically say, hey, does the node have a cost? If the node doesn't have a cost so far, then that means it has not been checked. Yeah, that's such a better system. Okay. So this is really good, actually. This is both an optimization and a feature improvement. So going from, one end of a big node heavy pathfinding map to the other 15 hops, it's 39 microseconds or something like that, which is really good. That means I could do like 100 of these before I am using like 2 or 3 milliseconds. 100 of these per frame, which is insane. That's really good. And then we still have the ability to turn off pathfinding for entire areas like that. And now, like if we want to go here, we can pathfind through there, but we can turn this off and then we have to go all the way around. Yeah. I forgot about that path. Yeah. That's very good. I'm happy with that. Really happy with that. That's working really well. I think it would help if I had a ground. There we go. This feels so PlayStation, dude. It's ridiculous. Oh wait, that's right. I was trying to do stuff with costs. I was trying to figure out how that works. Okay, so let's test this out. Hopefully it works. So if I press Q, that created a larger cost going down that route. So now it goes that route. That makes sense. Yeah. So it takes the easy way, and then if you press Q, now it can't take the easy way. It can, but it doesn't want to. So let's see if we can force it. So we shut off other means of going there, and now it goes down the hard way, the hard path. But if we have any other alternatives, it will take that instead. Very good. That's exactly what we wanted. Let's see. Let me see. It would be cool if I could like maybe cycle. Well, I guess I'll just do it like this. So now you can, cool. So yeah, you can be like, okay, all of these, all the paths that head out from this node are high cost now. So it'll try to find another way. Yeah, just like that. It tries to find another way around. But if it can't, that's really good. It avoids going through this way, like that, and it also avoids going through, yeah, going through either way. That's really good. But if we block it off, which way does it see? It's like, I do not want to take, don't make me take the short way. Yeah, and then it's like, okay, fine, there's no other way. Okay, very good. That's very good. Very cool. like that. Kind of like a pale red. I'm gonna probably rework these color names now that I think about it, because like, let me see, if you do like colors dot gray, it does give you some red. Okay, I guess that's fine. We'll do a pale red. Want to see if there's any kind of common colors in coding, like HTML. Okay, you do have some. Use red instead of... okay. Okay, that's pretty interesting. Let's see, 3C. Complete list, huh? Okay, I might use these. I'm just thinking about them. Thinking about it. That's something for next time. Okay. Cool. But yeah, that pale red I wanted to get here. It's... Is there any way, I wonder, to select... Is there any way to, like, grab a color... I don't think so. I was wondering if there's a way to like grab a color from the cursor, but not like sample the screen, but rather sample the color that's already there. But I guess maybe that's not possible. Okay, let's try this. Hold on. There we go. Excuse me. Is AD2C62. That's 175. 173, 44, 98. Let's see, 173 divided by 256. 0.67. Or is it 255? Let's see. Well, you can never get 256, so I guess it's 173 divided by 255. 6, 7, 8. 1, 7, 2. 0.38. 4. There we go. Yep. That's almost correct. It's kind of like a pink. Very cool. This example shows how grid point connections work. Connections between grid points are twofold. This is so that each connection from A to B and B to A can have different cost or passability values. Also, notes to select them. EK possibility from the node Q. Beautiful. All right, cool. That's what I wanted. Wait. Pass two creates creates a path going from the grid point to the given other grid point. The path generated should be shortest. taking into account both length individual hops. First possible route taking into account both the length and cost of individual hops. That's not possible from the starting point to the point, then path to a return nil. Okay. Cool, cool, cool. Did I ever use this? I do not. Instead, individual connections between group can have costs. Also, it's also been added for connections. Okay, cool. Connections between grids have a... Nope. Okay. We're good. Okay. Oh no, that's how it was before. Transparent. Oh no, that's yeah. Okay. No, that's how it was before. Okay. So there's just no change there. All right. Cool. All right. All right. Vector detection type. Properly. All right. Let's see. Okay, so this all seems fine. Cool. Massive commit. Now, something I always, well, not always, but something I wanted to do is have the ability to render a shape kind of arbitrarily. Because, like, if we look at this example, and let's change the music again. I don't know how much longer I'll be here. That's fine. Well, yeah, let's go with this one. Yeah, so something I wanted to do is add the ability to arbitrarily render lines and things like that in 3D. And I mean, it could be as simple as just like, you know, oh wait, how would I even do that? Well, I mean, like, there's different ways I could do it, but I mean, like, just rendering even like a cube in 3D space would be nice, I think. So I mean, like, what that would look like in this example, we have this system where we're basically getting a line object out of Blender, out of the scene, which is this guy. We're grabbing this line and then we're basically duplicating it and placing it on our grid point markers, and then we're stretching them and rotating them toward the thing that they're facing, which is fine. You know, there's nothing really wrong with that approach in terms of like, you know, it does work, but it would be nice if we didn't have to do it in such a kind of awkward way. It'd be nice if we could just be like, hey, draw a line here or draw a cube here. And in truth, I mean, like, there's a, you know, it's good that it works the way it does because it works pretty consistently and it looks pretty good. But, you know, it still would be nice to have the ability to render, still would be nice to have the ability to render shapes arbitrarily. So I'm trying to figure out like what that would even look like. Yeah, so I'm thinking that it's something like this, where you can say like, oh, I want to draw a triangle, or I want to draw a rectangle, a cube, or a sphere, or something like that. And so you basically can determine like, oh, you know, make a new triangle. Here's the points in world space, and then it will render using the camera. And you can add that to a list of, you know, you can render all of your shapes that way. That's the idea that I kind of had. Let's see if we can just kind of like bang it out. Let's see if we can just kind of figure out how this would work. For now, I guess I'm not going to worry too much about lighting and stuff like that. We're going to say that shapes aren't lit. Whoops. We're going to say that maybe they don't even have any, fog or anything like that. Well, I don't know. We'll see. We'll see. Can we just like grab all this code? Man, it's so much code, dude. And then just put it in here. Nah, I think it's better if we just straight up start from scratch. Okay, so here's how this would work then. So you say to render a shape. So we're just gonna skip a lot of this stuff. And get to the kind of the meat of it, which is here. We want to process the vertices. We want to then, we don't worry about lighting. Reach vertex index. We don't worry about lighting. For each vertex index, we clip it, so we still need to clip So we clip it. I don't think we're gonna use any UV stuff, I guess. I guess we're not gonna worry about that too much. And then we set the depth vertices. Vertex colors get set. And then we set the depth. And then we, I think, flush pretty much after that. I guess I could just do this like that, huh? Index list, vertex list index here, and then we just flush. Clip should be up here. If we're running, okay, so we clear the depth intermediate. Okay, and then we just do this. Okay. All right, so that is basically the lion's bulk of the code. Like the idea, anyway. I'm thinking that basically when the camera goes to render shapes, it should call render with the camera, but also we need some kind of base matrix here, right? Because we might want to like rotate the, well, I guess we don't want that. I guess we don't want that. It would just be like this. And even this, I'm not exactly sure. So let's just see if we could do something like this. Arrange. Okay. All right. Cool. All right, so then we have add shape, remove shape, and we also have, I guess we have a transform. Well, no, I guess position and rotation would be better. Yeah, like that. Because the idea is that we could provide a matrix to objects that need the matrix. Something like that, maybe. So then when you go and say apply a matrix, it would basically transform the vectors by the matrix. Something like that. Well, actually, yeah. And then when you go to render, it would basically be like, oh, temp v1 equals rt dot v1, 2, 3. And is it rt dot temp v1? Won't that v1? 3. Yeah, okay. Okay, then when we go to render, we actually use temp v1, 2, and 3. Okay. Because we have to basically like transform the vertices, and then when we go to render them, we have to actually do this. We're not gonna do that. So we could probably do this pretty simply if we just like I guess we could make it something like this. So shape group. And it's a shape render camera. Okay, so this also needs to, so then so maybe it takes a shape group specifically. And the idea is that basically you have to have a shape group because that allows us to have some kind of context. So maybe not even a shape group, maybe it's just a shape context. But basically the idea is like you can have some like global properties like position, scale, and rotation applied. Something like that. It feels like a general idea. I mean, I guess I could just use a node for this actually, now that I think about it. Because then you can like parent shape groups to each other and move them around, and it should all work automatically as long as we just call transform on this. Then we can basically pass the matrices into each shape when it comes to actually transforming them. That's an idea. I'm not sure how I feel about it. So what I wanted to do is basically just make like a really simple means to draw things in 3D, where you're not like forced to like a more immediate mode solution where you're just like, I just want to draw a line. I just want to draw a triangle. I just want to draw a plane. And to do that really quickly and easily. So I'm not really worried about like indices or stuff like that. Like vertex reuse, that should be fine. There's probably going to be no UV mapping. if we have a node. To maybe do this render. Maybe something like that. Prepare for render. Because then that allows us to put the necessary data into the things to make this work. So something like this. So really this is the same thing because it only renders a shape group. So I guess we can just do something like that. Prepare for render. Shape and range. Shape. Shape. Prepare for render. Camera. Oh, see. Okay, so we prepare the node, the triangles for render, and then we actually draw them here. So you have a shape group. It's a node. I mean, I guess I can make it so that the shapes themselves are nodes. Because then it just is basically a transform kind of thing. Where you just transform the vectors. Something like that. Okay, so then apply. Yeah, if I just make it so that this is a node. Well, I guess I could just make it like that, a node. Normal. Shaped triangle. Okay, it's starting to come together. I'm starting to like mentally like kind of see what I want, how I want this to work. So if you add a shape, then that just can parent the shapes underneath this. So the node shouldn't even be accessible. Nah, I guess it's fine. Like that, and then we can say ASG dot. Shape transformable. Well, I guess we could just do that, right? Apply matrix. It doesn't need that anymore. All right, so prepare for render. Yeah, I guess we could just say something like that. All right, so then when you go to camera, render shapes, we call transform to make sure that everything's updated, and then we prepare the shapes for render. I wish there was a better word for shape group. Maybe shape node. Shape triangle node points. Yeah, something like that. I mean, I guess I could do this a different way now that I think about it. Does the camera... Oops. Yeah, it is the mesh part. Yeah. So I'd have to make a mesh part. Like, I'm wondering if I can make, like, a shape that is essentially internally a model, but externally it is its own kind of thing. And I feel like I might be able to. I feel like that might be a better solution. Sorting tries. Then you're talking about sorting triangles. Well, I would have to sort the triangles. Man, this is an interesting and tough problem. I mean, really, I could probably, if I moved flushing out, I could probably just reuse flushing entirely. Almost. That might be the better approach, because a lot of this is gonna be the same. Do I even use the model? Just if it's transparent and the color blending mode, not fun. Yeah, I feel like I could probably like move this around.
I want some more.
Like, what if I went the stupid route and just made it basically a custom model that's a custom mesh for each shape group? So you define the, for example, vertex positions. The normals would be auto-calculated, I guess. It'd have to be dynamically calculated. That's probably the better route now that I think about it, because I'm thinking that I could probably do this in such a way where a shape is essentially a mesh, its own mesh, but it has a certain number of triangles or vertices maximum, something like that. And the different commands just move the data around. It's not instantiating any new data. It's just changing the existing data and cutting data off. So for example, if you want to draw one triangle, then you can modify, you know, one triangle's worth of vertices. And then if you want to draw 10, it can modify 10 triangles worth of vertices and basically be like, okay, where's the sorting triangles? It's in mesh part, yeah. And then it's like, okay, you know, we're only drawing one or two or whatever number of triangles. And then we can reuse all of the camera rendering code. We just need to make it think it's a mesh, essentially, a model of a mesh. And I feel like the better route. So basically, shaped triangle wouldn't even be a real thing, almost. It would almost rather be a function that returns, or a function that modifies a mesh on demand, and also sends data to the model. It would just indicate like how, I guess it would be the mesh part, indicate how, like where the vertices start and end on the thing. I'm thinking, and I feel like that's the right way to do it. Or at least that would be a better way to do it. Okay, so I'm gonna comment all this out. No idea if I'm gonna actually implement this, but I'm gonna write it out. Shapes would be cool. The idea, I think. Custom function, that. But it's really internally just a model. Okay, that's an idea. I feel like I could actually do it, and it would actually work pretty well. I'm wondering if I'm wondering if I could do UV. Maybe I could do UV. I mean, because I already have functions to create shapes. I mean, well, they're meshes, but it's essentially the same thing. Yeah, I've got quite a few of these. I wonder if I could... Oh, what if I did maybe... Maybe just something that allows you to, like... Because if we go back to this example, like, the problem here is that... I mean, like, really, even if you did this in code, it wouldn't even look that much better. Like, you still have to create a line of some description. You still have to set the position in some way. You still have to make it rendered somehow. and you still have to rotate it somehow. You still have to scale it somehow. So it's just, maybe I could do this in code rather than doing it like this. So maybe I just want something to basically say like new model. Something like that. Right, because then you don't have to clone this. You don't have to set that. Yeah, maybe that's what I would have wanted to do. Yeah, I don't know. I gotta think about this some more. But it's been real. I didn't really plan on doing a whole bunch today. I just wanted to kind of hop on since I was working. And I'll see if I can do more some other time. Actually, tomorrow. Tomorrow morning, I think. I'll try to hop on at like 10 a.m. or 12 a.m., 12 p.m. or something like that. But yeah, it's been real. Thank you very much for watching. I'm SolarLoon. If you want to support development and the stuff I'm working on, please feel free to check out my GitHub repository. Please feel free to check out my Patreon and itch pages and stuff like that. And I'll catch you guys on the flip side. Thanks. See ya.